Okay, we're going to look at operations on decimals, and we're going to use our grids from last time to try and add these together. So I'm going to first fill in the 2300ths. So I'm just going to use my little highlight tool, and I have 20, there's 2300ths. Now I want to add to that 5600ths, so I'm just going to draw it right here. And when we add, that's all about combining together. So let's see, we have 5 of these. That's 50. 1, 2, 3, 4, 5. Yep. And then we have 6. 1, 2, 3, 4, 5, 6. Okay. So when we combine those together, then that's going to be making, let's see if I line these guys up. I'm going to put all of my long ones together. So then we have a total of, you can kind of see it, there's 7 of those tall ones going on, but let's put our little pieces. So I have 3 of the pink ones. I'm a little far on that. 3 of the pink ones, and then we had 6 more. 1, 2, 3, 4, 5, 6. So then all together, you can see that I have a total let's see, there is 7 tenths, and then these guys, adding these guys all up, we have 9 of those hundredths. So altogether 79 hundredths. You can try that again. Let's see, we're adding now 4 tenths. So 4 tenths, and we want to add that to 35 hundredths. So here's 10, 20, 30, 1, 2, 3, 4, 5. There's our 35. So actually with this one, because it was a nice even amount here with no hundredths, we're saying that there will be a total of 4, 5, 6, 7 hundredths, and then 3, 4, 5, 75 hundredths, or we could say 75 hundredths altogether. So the next one we want to look at is subtracting. So we kind of get the feel for adding, I think, and even if I line them up, maybe if you don't want to see it horizontally, if we add them up, I'm lining them up on purpose based off of my decimal point, so that way my tenths are lining up. As you visually saw, we wanted to make all our tenths together, and then we added our hundredths. So that made 0.79. And so let's see how subtraction acts similar. So subtraction goes through with that whole idea of takeaway. So I start with having this 30, 32, there's 32. And so we want to take away 17 hundredths. So let's see what that looks like. So here's 10, 12, and then there's 13, 14, 15, 16, 17. So we want to take all of that out. And so you can see what is going to be left over is going to be one whole row, and then there are 1, 2, 3, 4, 5 of those left over, which then we would say, oh, well, that is going to be 15 hundredths left over. But if you look at what we were actually doing here, is we had our starting decimal, and then we said, okay, well, we want to take away. Well, you notice what I did first is I took away actually one of the tenths from the 3 tenths that we had, but then we had to kind of break up one of them because we didn't have enough. We had those 2 hundredths, but we couldn't take 7 away. So what happened is from really the 3, I had to take one of them away and really breaking it up into 10 hundredths. So these guys together, there are now 12 of the hundredths that I was able to subtract 7, and you saw that I had 5 left. And then you could think about the 2 tenths minus the 1 tenth would be the 1 tenth. So we'll see that one again in just a minute. So seeing the subtraction here, we have 5 tenths, so that's 5 of these columns, 3, 4, 5 of those guys. And now what we want to take away is 23 hundredths. So I'm going to take away 23. And so all those are gone. So you can see what we have left over here would be 2 of the columns, and there were 7 left over here. So that would be 27 hundredths that we have left over. So if I write it out, I'm gonna again line up, I need my tenths to line up, and you can see that I wasn't able to take away any tenths until I broke apart one of those 5. And so out of those tenths that I had left, I was able to subtract off the 3, and that left me with 7. And out of the 4 big columns, I subtracted 2, and I had 2 left over. So that leaves me with my 27 hundredths. Okay, we're gonna look at multiplying, again, kind of similar to how we did it with fractions, looking at an area model. So I'm gonna draw vertically my first, it could be the first guy, the second guy. So I have 2 tenths. So here's my 2 tenths. And I want to have 3 tenths of that. And so 3 tenths of that, I'm going to go horizontally and mark off my 3 tenths. And so you can see that the 3 tenths times the 2 tenths is going to end up being this overlapping section here. And so those are 6 little pieces out of the whole hundredth. So those are 6 hundredths. So we'd say 0.06. And so if you take 2 tenths times 3 tenths, you get 6 hundredths. So let's see how that looks like with the fractions. I'm saying the words for the decimals, but I really personally see fractions happening here. So 2 tenths times 3 tenths is going to end up being 6. Do you see how 10 times 10 here makes those hundredths pieces? So we have 6 hundredths, or as a decimal, 0.06. So let's try that area model one more time. Now this one might look a little crazy here. So we have 2 hundredths, and so we want to take the 2 little pieces. That's all we need, 2 little pieces. And then of those 2 little pieces, we want to take 3 tenths of that. Now what that means is we need to break this up into 10 pieces. Pretend 8, 9, I think we have 10 pieces that way. And so what we actually want out of those is 3 of them. So I'm going to highlight out of that little section there, 3 of them. And so what is this talking about? Well, those 3 little sections there, when we do that, we're taking hundredths and turning them now into thousands, because each of those pieces, this long piece right here, is going to be 1,000th. Because every piece of these 100, you're going to be able to break into 10 more, so those are now thousands. So you look what we have. We have 1, 2, 3, 4, 5, 6. And so that's going to be 6 of those thousands. So that one is really hard to draw, but just trying to see a visual of how this is happening. So 6 thousandths means this is going to be 0.006, right? Tenths, hundredths, thousands. I kind of like this one a little bit more, seeing it with the fractions. We have 2 over 100, that's 2 hundredths, times 3 tenths, and there you can see it expanding to be 1,000 right there, 0.006. So again, with those fractions, you can kind of notice this pattern that's happening. So these are tenths right here, that's the place value, and then this is going all the way to the hundredths. So when you multiply tenths times hundredths, you could see you get thousandths. And so if I rewrite this as 52 tenths times 134 hundredths, this is going to be equal to 6,968 thousandths, which, if we have decimal point, tenth, hundredths, thousandths, so I'm going to write it backwards, 8696. That should make sense that we have a whole because this is actually an improper fraction. But this would be the answer to that multiplication. And so the pattern that you might be noticing, or that you remember from some class, is that you have one decimal place, two decimal places here, and so you're going to end up with 3 decimal places. And so really you just need to multiply, and this is our kind of algorithm for multiplying decimals. You really just need to multiply the numbers that you see. So we see, ignoring decimals, of 52 times 134. And then you recognize their place values. And if you recognize their place values, that they're going to become now hundredths. Now decimals are really easy to enter on your calculator, so you might want to try a few more just to make sure you understand why that's working. And you should be able to show why it does work. Why is it that the decimal places kind of add up? All right, we're going to move over now to division. And we're going to use the 2 meanings of division that we saw before, which were using this dividing number to be how many groups there are. And so the question, if there's 3 groups, is how many in each group? Or how much in each group, I should say. So I'm going to draw the picture of the 54 hundredths. So 54 hundredths, 1, 2, 3, 4, and 1, 2, 3, wait, 54. There's 5 hundredths, 5 tenths, 1, 2, 3, 4. There we go, 54 hundredths. And so we want to break them up into groups of 3. So if we're going to break them up into groups of 3, I know that each of them is going to be able to get one of these big guys for sure. And so that's going to start to make up a group. So everybody's going to get one of these. Okay, so they're able to get that. And then I noticed that I have 24, let's see, 10, yeah, 24 left. So that means everybody's going to be able to get 8 more. So it looks like that would be able to make a whole group. And then these guys, that's 12. How many more do I need? 6 more? 6 more. Those would be able to make a group. And then 1, 2, 3, 4, 5, 6, 7, 8. I think I might have been off by 1. This should have closed in there. So we're going to get another group here. So let's break that up a little bit better. I'm going to use the color to see it here. So what I'm saying is that there should be able to have 3, 4, 5, 6, 7, 8. And then the next group should be able to have one whole one of these, and then there's 2 there, and 3, 4, 5, 6 there. And then the other one will have a whole guy, and 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So all together, this is the 54 hundredths, and we were able to make 3 groups, 1, 2, 3 groups, and each group had 1/10 in it, and then 8 of the little hundredths, or we could say 18 hundredths. In the next one, we're going to look at it slightly different because this 0.04, it's hard to make that many groups. So instead, let's say that this is the size of the group, and we want to know how many groups there will be. So I'm going to start by drawing what I have, which is the 27 hundredths. So there's 27 of the hundredths. And I need to break them up into groups that have 4 hundredths in them. And so I'm going to draw this. Let's see, he's red. So I have 3. There's one group. There's another group. There's another group. Another group. Another group. Another group. And I'm off by 1. That guy's short one. So it looks like I was able to make 1, 2, 3, 4, 5 whole groups. Oops, I missed one. 6 whole groups. So there's 6 groups, but then I only have 3 out of the required 4. So really this is 3/4. So I have 6 and 3 of the 4 that I really needed. So that's the answer to my division problem, but actually we should write that as a decimal, which is going to be 6 and 75/100. So let's take a look at the next one here. We are going to do kind of the same thing again, but this time we're looking at putting 8/10 in a group. So if we have 2 wholes, that's actually all of this and all of this, and we have 4/10. So this time if we want to put 8/10 in a group, that means I'm going to put all 8 of those. There's one group, and then there's 2 through 5, 6, 7, 8. There's another group, and then 4, 5, 6, 7. Woohoo! I was able to make 3 whole groups. So 2 and 4/10 divided up by 8/10 makes 3 whole groups. Again, all of these you can check by doing that multiplication back. Now, without the grids, but with fractions, we can say, well, this is 24/10 divided by 8/10. And what we've seen with fractions is that we can rewrite this as multiplication by the reciprocal, which ends up being 240 over 80. Or you could have said, well, that's 24 and 10, and that's 8 and 10. So I can reduce by 10. And so I actually have 24 over 8. But again, this is 8 and 3. So we can reduce by 8 and make 3 ones, or the number 3. So there's a few different kind of models for this division. We're going to try one more. And I'm looking at 75 and 45/100. Again, you can write it as the fraction, and maybe I'll show that to you first. 75 and 45/100. We're dividing that by 3, but that again can be rewritten as 75/45 over 100 times 1/3. And on this one, I'm kind of thinking about really rewriting it in this way because I want to write it out of 100. So I just rearranged the 3 and the 100, which I can do because of the commutative property of multiplication. But what I'm thinking is if I just divide these numbers, ignoring all decimals, if I just divide that for a second, 75/45 divided by 3 ends up being 25/15. So that's basically like regular division. But then we still need to consider that there was hundredths. So when you multiply by 100, we're going to get 25/15 divided by 100, or we can rewrite that as 25. Let me erase that. 25.15, because we have to land on the hundredths. We know that that's only 2 decimal places. If I set this up as like a long division, what we're saying then is that we do our regular division like we're used to, but then you can just keep in mind your decimal at the end. So it's really nice to divide by a whole number, because then your decimal point will end up just going straight up. Just like you saw here, we ended up having 2 decimal places, and that's what we started with as well. And so again, kind of ignoring that there's a decimal, we could do 3 goes into that 75. Well, we could do 2 goes into the 7, or 3 goes into the 70 twice. That uses up 6 of our 10s. 1 10 left over turns into 15 ones. 3 can go into 15 5 times, which uses up 15 of our 1s. Then we have these 4/10 that we're breaking up. And we can give everybody a 10th there. That uses up 3 of them. We have 1 left over, which will turn into hundredths. So we have 15 hundredths, which will get 5 hundredths to every person. So you can see how those place values are all holding up. So if we flip the page, if we want to look at this 32 and 172 thousandths divided by 21 hundredths, we could turn it into the problem on the previous page, by really thinking about our decimals as fractions, well, knowing that when we're multiplying by like 1,000, that's really allowing us to move that decimal place 3 spaces over. And the same thing on the bottom ends up being 210. And so this is actually a whole number divided by that 210. So as we try and work that out, let's see, we'll go 1 time, that will be 210. We subtract, get 111. We'll bring down the 7. That goes 5 times to make 1050. Subtract that. We're going to make 67. Well, that would be a 7, so 67. And then we'll bring down the 2. That will go 3 times. And 3 times the 210 will be 630. We left with 42. And so we have that 42 left over, but really that means we just need to start breaking up our ones into tenths. So those 42 tenths can turn into 400, or those 42 ones can turn into 420 tenths. And so we're now talking about a tenths place. So that will go twice and use up all 420 of those tenths. So we have 153 and 2/10 as our answer to that. All right, the last one kind of usefulness in working with the decimals is to find something sometimes you'll hear as a unit cost. So if we have 1.29 divided by 20, we could take 1.29 and we could divide that nicely by 20. Again, we're going to just stick our decimal straight up because this is a nice whole number there. So 20 can't go into 1, it can't go into 12. So we're saying, okay, well, let's look at this as 129 hundredths. So that could go 6 times. So 20 times 6 hundredths is 120 hundredths. So we have 9 hundredths left over. So we could turn those into 90 thousandths. And we can break that up into 4. That uses up 80 of them. We have 10 left. Let's break those up even more. And we can do that by 5, which makes 100. And we get 0. An alternative way of doing that is to rewrite this 1.29 if I rewrite it as a fraction. I'm just showing you kind of both ways so you can see that they really mean the same thing. So 129 hundredths, and we're dividing by 20, but really that's 21s. So we're going to take 129 divided by 100, then multiply by 1 over 20. And so this is equal to 129 over 2,000. Now, if we want the decimal for that, what we saw earlier was that we can rewrite this as a power of 10. So this is 2 times 10 times 10. That's 100. One more 10 in there. So really, I just need one more 5 to make an extra 10. So multiplying the top and the bottom by 5 gets me 645 over 10 to the 4th. So I have a 110 here, a total of 4 tenths. But that would just mean 0.64, oopsie, not 64. These are thousandths, so we need tenths, hundredths, thousandths, 10,000. So 5, 4, 6, 0. So we get the same thing. So just kind of 2 different ways working with the decimals converted to fractions, and the other way doing our long division with the properties needed for decimals. So we'll try this again. So I have $130 or $1.39, and I want to divide that by 20. So if I take 20, setting that up the wrong way, $1.39 divided by 20. I'm going to set up the long division the same way. So I know that I have to think about it as 139 thousandths, or hundredths, I mean. And that could go, let's see. Oops, not by 20. let's erase that. We gotta fix that. I'm sorry. That's 32. You're like, what's happening? 32. So if I'm looking at it going into 32, that would only work 4 times. So 4 times the 32 is 128. So that uses up a lot of them to only have 11 left. And so we'll turn those into thousands now. So 110, or 32 can go into 110. That would be 3 times. So then that uses up 96 of them. And so then we're going to be left with 14. And we're going to keep kind of continuing, but I can actually stop right now because this would take a little bit longer. It does terminate, but I notice that right now what we're talking about is money. And so this right here is our change that we're talking about, really. It's 4 cents, and this would be not even, it's 3/10 of a penny. And if you look at the money that we had up here, we have a 6 versus a 4. So if we're going to compare these guys, 6 tenths or 6 hundredths versus 4 hundredths, or 6 cents versus 4 cents, the better buy would be the 4 cents. Well, if you really want a 32-ounce beverage, but that would be the best buy per ounce. And that's all we got.